All right, here's our second section of notes. We're going to talk about the quadratic formula and the discriminant. So, as we've already been identifying, a zero of a function is where y equals 0. So it's the x values that make our function equal to 0, or y equal to 0. Wait, let me fix that. Okay. So, a zero of a function is the same as an x-intercept if the x value is a real number. So that's what we've been talking about. When we have x-intercepts, we have real solutions, and then when we can't find that x-intercept, we call it no real solutions. And we're not going to get into imaginary yet, but that is coming. And then as we've identified, a quadratic function, it could have 1, 2, or no zeros, right? So we could have 1 x-intercept, 2 x-intercepts, or 0 x-intercepts. Therefore, right, so 1 x-intercept is our graph sits on the y-axis, our parabola. 2 x-intercepts, our graph intersects, our parabola intersects the x-axis twice, and 0 x-intercepts, it never intersects the x-axis. So we've already talked about this a little bit. So there are some quadratic equations that are not factorable. So as we look at this first example, which is in standard form, we want to try to factor it, okay? But the factors of 14 are 14 and 1, or 7 and 2, and no combination of those will give us 7 in the middle. So this is an example of a non-factorable equation. So then what we can use now, and what we are introducing, is this nifty little thing called the quadratic formula. And if you were here on Friday, or if you're watching this video after you came to class, then hopefully you've had a chance to hear the beautiful rendition and maybe see a couple fun videos about the quadratic formula. But the best way to remember it is honestly with the song. There's two different versions, one to Jingle Bells, one to Pop Goes the Weasel. So let's see, it's x equals negative b plus or minus radical b squared minus 4ac all divided by 2a. That is one version. Thank you very much. And then the Pop Goes the Weasel version is probably the one we heard in class. So we can use that, sorry I got distracted, we can use that to solve the non-factorable equations. So the BAC, right, come from our equation, which we are familiar with. Whatever's in front of our x squared is a, so in this problem a is 1. Whatever's in front of our x term is b, so our b here is negative 7. And then whatever our constant is our c, so our c here is negative 14. So we're going to plug those values into our equation. X equals negative b plus or minus radical b squared minus 4ac all over 2a. Hey. Okay, so I plugged in my b right here, negative b plus or minus b squared minus 4 times a times c all over 2 times a. So a lot of numbers, and then we got to look to simplify. Okay, so the negative 7 is going to make that front term a positive 7. We're going to have plus or minus still. Then under my square root, I've got b squared, that's 49, minus 4 times a times c. So 4 times a times c, I've got this negative here and the minus out in front, so that's going to become a plus because I have only one negative there. And then 4 times 14 is 56. So I've got 49 plus 56 under my radical, and then on the bottom of the whole thing, I've got 2. So now I keep simplifying. X equals, I've got 7, I've got plus or minus 49 plus 56 is 105. So I've got the square root of 105 over 2. Okay, I need to simplify the square root of 105. Let's see what the factors of 105 are. I know 5 goes into it. How many times does 5 go into 105? Let's see, 105 divided by 5 is 21. So I am over here, I'm going to just simplify my 105, make sure I can't simplify that radical anymore. So this is 5 times 21. 21 is 3 times 7. Okay, those are all my prime factors, and there's no buddies there within my radical, so 105 is reduced. So then I can't reduce it anymore, so this is my answer, believe it or not. As funky as that looks, that is x equals, and then we have two different x-intercepts there. We have 7 plus the square root of 105 over 2, and we have 7 minus the square root of 105 over 2. So two different answers, two x-intercepts. Tell if the following equation has 2, 1, or 0. This has two x-intercepts. All right, so quadratic formula. Let's try another one. All right, x equals negative b. First, before we go, we notice on this one that there's a 5 over here. We cannot have numbers on both sides of our equation. We need to have it equal to 0. So I'm going to subtract 5 from both sides. I'm going to have 2x squared minus 3x minus 20 equals 0. Now I can use my quadratic formula. There's my a, my b, and my c. Okay, x equals negative b plus or minus radical b squared minus 4 times a times c all over 2a, 2 times a. Okay, now I gotta simplify all this. Negative b becomes a positive 3 there, plus or minus radical b squared minus 4 times a times c. Again, I've got one negative within that 4 times a times c, so that is 8 times 20. So that becomes a plus because I have the minus and negative. It's going to be plus, and then 4 times 2 times 20 is 160. There's people outside my door, so I will pause the video and come back. All right, we're back. You're fine. So we gotta keep simplifying here. This is 3 plus or minus the square root of 160 plus 9 is 169 divided by 4. Square root of 169, that's a perfect root. It is 13. So this becomes 3 plus or minus 13 over 4. That is 3 plus 13 over 4 and 3 minus 13 over 4. 3 plus 13 is 16. 16 over 4 is 4. There's one of our x-intercepts. And then 3 minus 13 is negative 10. Negative 10 over 4 reduces to negative 5 halves. So there's our other x-intercept. All right, so again we have two x-intercepts. Okay, now we have a little Easter egg to see who's actually watching the video.
Draw your best chameleon next to where it says example 3.
Next to where it says example 3?
Yeah.
Okay, so right here.
Yeah.
Best chameleon, you
From
heard it here.
and Mia Murrell.
Okay, thank you ladies.
Bye.
Thanks for your help.
No problem.
Okay. I want to see those chameleons when I check your notes the next day. Okay, so same as before, we gotta subtract 4 from both sides to get it equal to 0. So we have 4x squared plus 8x plus 3 equals 0. And then now we're gonna use our quadratic formula, a, b, c. Okay, I would like you to see if you can plug those numbers into your quadratic formula. X equals negative b, etc. See if you can plug it in and simplify. And we'll go over it in class when we next meet. Okay, go to the next page because the summary box is there, but the notes actually finish on the next page. So the little piece that's under our radical is called our discriminant. Okay, that's just the b squared minus 4ac part. And what we can use that discriminant for is to determine how many roots our graph is going to have. So if we have If our discriminant is greater than 0, then we will have 2 solutions. If our discriminant is equal to 0, then we will have 1 solution. And if our discriminant is less than 0, then that would mean that we had a negative under our radical. And so that's when we get those no real solutions. So let's see what the discriminants are for these, and it'll tell us how many x-intercepts we have. So we just do the b squared minus 4ac part. So b squared is 8. So we're going to go b squared minus 4ac. That is 8 squared minus 4 times a times c. 8 squared is 64. Minus 4 times 1 times 16 is also 64. So our discriminant is 0. When our discriminant is 0, we have 1 x-intercept. That's all we have to do on that one. Okay, then we're going to find the number of solutions by using the discriminant, b squared minus 4ac, b squared minus 4ac. So b is negative 4. We're going to square it, multiply it, or subtract 4 times a times c. Okay, it's going to be 16, and then we're going to end up adding here because we have this minus and then a negative. So that is 16 times 8, which is 128. Add that to 16. I mean, regardless here, all we're looking for is whether or not it's going to be greater than 0. 144 is greater than 0, so we have 2 solutions. Okay, again, b squared minus 4ac. b squared is negative 2 minus 4 times a times c. So that is 4 minus 24, which is going to be negative 20, which is less than 0. So we have no real solutions. Emphasis on the real, because again, we're going to be doing imaginary in a couple lessons here. All right, and then this last example, you do on your own.